Zoom here. Well, good morning, everybody. Today is September 3rd, and we are in ES 1060. And I just want to catch up to the point where we are, because September 1st was Labor Day. We did not have lecture or lab, so this is a short week. So really what we're doing is not really presenting a lot of new material. We do want to talk a little bit about pseudocode and sort of a tech stack. But in general, what I want you to do is to just take this time to sort of get caught up on where we are with our work. Okay, so I want to make sure everybody is up to speed on this temperature conversion problem from using pseudocode. So let me pull this up and we can look at some of this stuff, because there are two aspects to this problem, and they sort of speak to a situation that has to do very much with engineering. Okay, so the first thing that I would like to say, we have 10 problems here, and the calculations are fairly straightforward. But there are two things that I want to make a point of. First of all, every answer on this assignment is a number in the approximate correct number of significant figures, and I say approximate, plus a unit. Okay, so for example,
are we supposed to be able to see what you're writing?
Oh, not right now. You will in just a moment. I'm going to put up a problem here so that I can work this out. Give me just a second. This is number 7 minus 500 degrees centigrade equals how many degrees Rankine? Okay, so let's take a look at that one. Now I'm going to stop the share and you'll be able to see what I'm writing. How's that? All right, so here on the board, every answer is a number in an approximate number of significant figures plus a unit. And the other part is an answer to a math problem may or may not be a solution. In other words, the answer has to be valid in order to be a solution. So let's look at this problem. Negative 500 degrees C equals how many degrees Rankine? Okay, so the first thing is that the first thing we would do is do the math. And we have a couple of different theories. We could, for example, convert degrees C to degrees Fahrenheit. And then we could convert degrees Fahrenheit to degrees Rankine. Well, let's go ahead and start that way. We know that the conversion between degrees C to degrees Fahrenheit is if we take degrees C, let's go ahead and I'm going to go work this out. I know you don't have to do this every single time, but if we look at centigrade scale and Fahrenheit scale, we know that 100 degrees here is 212 degrees here. 0 degrees here is 32 degrees here. So to do this conversion, the first thing is we see that the span is 1.8 or 9/5 of a degree. And we also know that there is a factor plus or minus 32 because of where the 0 comes in over here. And so how that works is if we think about 100 to 212, we can see that the degrees Fahrenheit is going to be a larger number. And we can also see that the degree Fahrenheit is going to add 32. So in other words, if we take 9/5 times the degree centigrade and add 32 to that number, yeah, that's right, then we will come out with degrees Fahrenheit. Okay, and we could test that by putting in 100 here. 100 times 9/5 is 180 plus 32 is 212. Degrees centigrade, 0 plus 32 is 32. So you can see that that checks if you didn't remember the formula. You can also just remember the formula, which is the easier way to go about it. But so if I'm going to do that conversion, then I would take my degrees C, which would be minus 500. And I would multiply that by 9/5, and I would add to that 32 degrees. So if I punch that into my calculator, I get negative 500 times 9/5 And then I add to that 32. And I get the answer negative 868 degrees Fahrenheit. Okay? Now, if I want to convert to Rankine, remember Rankine, oh, sorry. My Zoom is messed up. What do you mean? Tell me.
Full screen.
Oh, am I not getting everything? What do you want me to do?
I think you just click into the window, will make it. So it's.
So you want me to view it differently? Is that what you're saying?
So, yeah.
All right. Oh, you're speaking, so there we go. So,
Not speaking.
I know. um,
Are you muted on those?
mhm.
It would be telling us. But then the feedback. Yes.
I don't want to remove or report you. I'm not really sure how to do that. Do you again?
Just click into the window. It should make it full screen.
That plus escape.
Why?
Yeah, it's not doing it. You see what I'm doing?
Yeah.
I'm sorry. I don't. Let me see if I start talking. Let me go ahead and do a speaker view again.
If you right click your top one there and click pin, will that do it?
Let's find out.
This box, there's a pin down there.
There, yay, success. All right, very good. All right, so there we go. So anyway, so we have a number as negative 868 degrees Fahrenheit. The next thing that we want to do is convert Fahrenheit to Rankine. Well, what do we know about Fahrenheit to Rankine? We know that 0 degrees Rankine, which is absolute zero, is 460. I always forget that number. Degrees Fahrenheit. How many degrees Fahrenheit is absolute zero? 459. Yep, negative 459.67. There you go. Okay, so that tells me that from degrees Fahrenheit,
Say 0.7.
sorry,
Did you say 0.7?
17.677, yeah. So, but I can use, I'm happy to use 460. Just to simplify things, okay? All right. So if I plug this in and I say 0 degrees Rankine is equal to negative 460 degrees Fahrenheit, what I can see is that to get from Fahrenheit to Rankine, I have to say degrees Fahrenheit plus 460 degrees plus 460 equals degrees Rankine. Okay, so to change this to Rankine, I would say negative 868 degrees Fahrenheit plus 460 equals degrees Rankine. And if I do that number, I get that my original number equals negative 408 degrees Rankine. Okay? What's wrong with that answer?
You can't have negative Rankine.
That is right, but 0 degrees Rankine is equal to absolute zero.
So does this mean that negative 500C doesn't exist?
That is correct. So therefore, negative 500 degrees centigrade
Validate.
is invalid input. So when you're doing your homework, this is the numerical answer to the math problem, but the solution to the problem is invalid input, or you could say does not exist, or below absolute zero, or something indicating. But what I'm getting at is, it's not just the math. We have to do this in order to come up with an engineering solution. And this happens over and over again in engineering. This is like the piece that we move on from the math to putting math as being a representation of the physical world. Okay, so when you do your homework,
We just didn't have those two.
keep, oh, very good. I'm glad to hear that.
Basically, the thesis here is a valid mathematical output is not always a real world valid answer.
That is such a good thing to remember.
They're not always solutions.
There you go. Yeah, so that is a very good point. And that's also getting back to the idea of significant figures. This didn't really present itself, but if you look at this number, the input, negative 500 degrees centigrade, how many significant figures does that answer have?
One.
One, exactly. So that means that if it were a valid number, and my answer turned out to be negative 408 degrees Rankine, how should I actually write that number? If it was valid?
Was negative. What was the answer?
Negative, let me stop my share, so we'll do this.
Sorry, I was.
No, it's okay. Negative 408,
Be negative 4.
it would be negative 400 degrees Rankine. And then, of course, we would have to note it's not valid, right? That it doesn't really make sense in the real world.
When we're
Wait, why
coding,
would it be negative 400?
Because there's only one significant figure, so the 8 makes it 3 significant figures.
But it's the same,
The same magnitude,
Yeah.
we're measuring by degree.
significant figures are
Yes.
happening in their rules.
Right.
It takes a while to just
Right.
kind of,
but 500,
I reached a point in my life where I
so is
have
5
accepted that.
significant figures?
Sorry, you're both talking, so I can't hear you both, so you finish.
I said, I've reached a point where I've just accepted that
Exactly,
significant figures don't make sense and you just have to learn the rules and accept them.
that's right. Now tell me what you said.
So is 5 a significant figure or negative 500?
Yes,
The zeros follow.
the zeros are not. If the zeros were significant, there should be a decimal point after it.
Yes.
So in other words, 500 point means there are 3 significant figures. And we don't really have, here's another interesting point.
So
Go ahead.
the idea is that the last figure is always estimated. So when
Yes.
somebody says 500, they don't know it's 500. When they say 500 point, they know it's exactly 500.
This means about 500 degrees, right?
So we can't say 408 because our initial number 500 was not specified. in
Right.
that.
This means if you put a decimal point, that means it's measured to a degree. Here's another one. We don't really have a way to express measured to tens, except using scientific notation. So in other words, there's no way to write, this means you have 2 significant digits. That means this is significant, but this is not. If this were significant, you would have to write it like this.
And if it's not, then you just 5 times 10.
Exactly. So, but Deegan, to make the point that you're making, which is also true, like I said on the first day, this would be if you're in chemistry class. And when we talk about temperatures, you may work on that in chemistry. You need to follow the actual rules of significant figures. For engineering, I like to think about what you just said, which is it's a measurement. You've measured this to a degree. Can we measure this to a degree? You know, that's also a valid way to look at it. What I really don't want to see is 5
Or that's
to 8.6467.
when you started with 5.
Exactly.
I get that, that makes
Yes,
sense.
yes.
Like, I did not know that about significant figures, like so that.
The only ones
to
that,
know,
yeah.
I'm very. significant.
If you think about significant figures, I'll give you the rules really quick. And once again, if you're working with your chemistry, with me, this is good enough. 500 degrees, 508 degrees, or 408 degrees. So those are good numbers. Because they're based on the way they're measured. If you really are working with significant figures, here's the rules, if you want to simplify them, because I'm an engineer and I like things as simple and as clear as possible. First of all non-zero digits are significant. So the only thing we ever have to worry about are zeros. So the question becomes, when is a 0 significant? And the answer is, there's 2 answers. When it falls between 2 non-zero digits. So in other words, 408, that's significant. 0.867, also significant. Oh, wait,
0.0087, those two are not.
sorry,
0.0087, those.
this is another one, right? When it falls between or on the left, which is the part that doesn't make sense to me, but it's still true, on the left of non-zeros. 0.0067.
So,
These are significant.
so there's, so if you were to write that in significant, or like, I guess.
Yes. They're not, they are also significant if between a digit and a decimal. So in other words, 500 point, these become significant. If they are on the right of a decimal, 500.00, those are also significant. So I guess it's easier for me to think about when zeros are not significant. First of all, everything's significant except zeros. When are zeros not significant? Basically, when they're over here on the right hand without a decimal point.
But then we don't usually write those anyway.
Exactly. But if you have the number 500, you have to write it as 500 unless you put it in scientific notation, because we don't have an Arabic numeral way of writing 500 with one significant digit, except to say you have to put the decimal point on it in if it's significant. So how's that? But in this class, write it like it's measured. So I go back to what Deegan said, absolutely.
Thank you.
Yes, absolutely. Well, and I think this is important stuff. So the big thing is, so we're going to meet on Monday in lab, and like I promised you, we're gonna have a short class today. We're gonna meet Monday in lab. We're gonna do the next section of MATLAB, right? The next onboarding. And we're gonna start talking a little bit about pseudocode. I mean, in the specifics of writing pseudocode, but pseudocode is basically, as we said last time, it's how you would code it regardless if you're language agnostic. You know, you don't have it, you're gonna write it in MATLAB, you're gonna write it in Python, you're gonna write it in Fortran, you're gonna write it in assembler because you're insane.
Don't know how to do this.
But see, if you know exactly how to write it in Python, you've already conquered 80%. So the big deal is that when you are writing computer code, as I said last time, the computer, the code will do exactly what you tell it to do. It's just, you know, sometimes like when you do math problems, or any sort of a problem in real life, even if you're writing a document or whatever, you can sort of start out with a vague idea and work your way down to what it does. But every time you do that with a computer program, it will belch something out, and that something may or may not be valid depending on what you put into it. So we just need to, that's what pseudocode does, is help you codify that. So like, for example, on these problems, let me stop my share. We're gonna have some sort of a code that says, for example, let's just do the one that we just did. If we have negative, what did I have? Negative 500 degrees centigrade. Convert that to degrees Rankine. And we have two different ways. There are two different things we have to do. We have to do the math, which is degrees C to degrees Fahrenheit, and then degrees Fahrenheit to degrees Rankine. Okay. Then the next thing we have to do is to check. And so we have to develop a little structure called an if structure. If this is below absolute zero, whatever that means, then tell it, you know, bad data, no bueno. Right? Whatever you want to say. And if it doesn't, then give it an answer plus the unit. Okay, so this if structure is really part of the program. That is something we haven't discussed yet, but MATLAB is gonna lead you through it. You can also do it very easily in Excel, which you may be tripping to the idea that once we start Excel, this is one of the problems we're gonna solve using Excel as well. So that's why I want to do the pseudocode. So everything, what I'm really trying to do from an instructional point of view is to lead you to the point where all the problems you have when you code in MATLAB are MATLAB problems. And all the problems you have when you do it in Excel are Excel problems. I don't want to still be messing with the structure of the problem itself. So that's why we're going through it like this. So, you guys have any questions for me? I really appreciate all the input from you guys. I mean,
I do have one question.
oh, yes, please.
We are going to write a program in
Yes.
MATLAB that does this.
Yes,
Then we're going to write one in Excel.
yes. And we're gonna write lots more. We're only gonna write 2 programs in MATLAB. The first one is, I don't know if you guys are familiar with, just programming history or programming legacy. But, okay, so one of the things that often happens in when people open up a code is they'll do a little program called Hello World, which is just, right, so you're kind of acknowledging that nothing's happening yet, yeah. So we're gonna write a Hello World program code in MATLAB, and then we'll write this code, spend some time on that. Then we go to Excel, we're gonna do a lot of different codes because Excel is really the main tool that we're using in here. But we'll do some of those similar things with Excel. All right? And Excel, I shouldn't really call it a programming language. I should refer to it as a programming environment. You know, I mean, it's really, what's that? There you go. It's a development environment. Exactly. So so that's it for today. So everybody, this is recorded. Everybody who's here, I don't think you're gonna have to watch this, but I really wanted to firm this up for everybody who is, we have 2 students who don't come to, who aren't in this class physically usually. So want to make sure that they're at the same place you guys are. So that's what today's all about. So Monday we'll be back. We'll start talking specifically about pseudocode. And we'll answer any questions you have about the homework that will have been graded over the weekend. And then we'll do lab where we continue with our journey through MATLAB.
I have another MATLAB question.
Okay,
When it basically, I did a thing and it didn't make sense.
okay,
I don't know how much input you will have on that. So I had a, we call it a vector.
okay,
I had a vector defined as one, it's set of numbers 1, 2, 3.
mm-hmm,
And when you multiply 2 vectors together, one vertical and one horizontal, you get a matrix.
yes,
When I multiply, so I had, so B equals the horizontal vector 1, 2, 3. And then I had another parameter I defined as V flip, where I flipped that vector to be vertical 1, 2, 3, the column of 1, 2, 3. So now I have 2 parameters that I can multiply together to get a vector, or to get a matrix. 2 vectors.
Yep.
One's a row, one's a column. When I multiply V flip by V, I get that matrix. I get
Yes.
1 times 1,
yes,
2 times
2 times 2, 3 times 3,
3 times 3.
yes,
It looks like a times table.
yes,
When I multiply V times V flip, I get 14.
oh, because. Hold it. Which kind of multiplication are you using? Are you, okay, there's 2 types of multiplication. And this is not just in MATLAB, this is like for everybody. If you multiply 2 vectors together using what's called a cross product, it's a vector itself or a matrix, okay? If you multiply 2 vectors together using scalar multiplication, it's scalar. So what you've done is, I think you have used the function that is scalar multiplication.
I use the same symbol.
I don't know how to answer that then, but it's a dot product as opposed to a cross product.
So it's like U times
Yes.
V over absolute value, something, right?
No, it's just, I'll go
I
ahead
don't
and work.
remember how dot product.
Let me show you here. So it's like this. If you have two vectors. And the shape of the vector doesn't really, I mean, whether it's horizontal or vertical, whether it's a 3x1 or 1x3. That's sort of outside this conversation if you use scalar multiplication. But the dot product of these two would be just the first elements multiplied together, plus the second elements multiplied together, plus the third elements multiplied together. So that's 1 + 4 + 9, which looks like 14. You said 13 or did you say 14?
14.
Okay, good. Then at least we're doing okay there. But if you do it this way, then you have a different situation where you take every row. So it's IJK 1, 2, 3, 1, 2, 3. And then you multiply, you choose a multiplier row like this. And it's I times this small vector 2, 3, 2, 3 minus J times the small vector 1, 3, 1, 3 plus K times the small vector, excuse me, the small matrix 1, 2, 1, 2. And then you have to execute these. So it's I times 6 minus 6 minus J times 3 minus 3.
What is it called when you can move like multiplication around? 3 times 2 is the same as 2 times 3?
That's the commutative property.
It seems that that's not true here.
Vector multiplication is not commutative. That is correct. Well, when you get into calculus, I'll explain that. It's a little mathy for this level, but it's actually because of what's called, I'm gonna have to turn off my, hang on, I'm gonna just turn off my recording.
Yeah.
Hang on just a second. All right, guys, that's it for today. See you later. Have a great day. Let me know if you have any questions.